Okay, welcome to the 2011 AP Calculus review video. We'll be going over the 2011 exam, and let's start with the first question. So for t between 0 and 6, the particle is moving along the x-axis. We don't know its position, but we do know its velocity and acceleration. We also know that the initial position is 2. Part A asks, is the speed of the particle increasing or decreasing at time t equals 5.5, and why? Okay, so for this question, we're looking at speed, right? And then when you want to figure out whether speed is increasing or decreasing, you actually have to look at both acceleration and velocity, okay? So what we're going to do is we're going to find both acceleration and velocity at t equals 5.5, okay? So we'll start with the velocity at 5.5. So we'll plug in 5.5 in for t, and we'll get 2 sine of e to the 5.5 over 4 plus 1. And if you put that in your calculator, it comes out to be negative 0.453. Okay, and then we'll also find the acceleration at 5.5. And that means we'll just plug in 5.5 into the acceleration, and we'll get 1/2 e to the 5.5 over 4 cosine of e to the 5.5 over 4. And if we put this in our calculator, we get negative 1.359. Okay, now what you have to look at now is you have to look at the sign of the acceleration and the velocity. If they have the same sign, it's speeding up. If they have opposite signs, it's slowing down. Okay, so as you can see here, since both velocity and acceleration are negative, they have the same sign, that means it's speeding up. So the answer to this question, you'd write this down on the actual test, is the speed of the particle is increasing at time t equals 5.5 because both the velocity and the acceleration have the same sign at t equals 5.5. Okay? This was a 2-point question. You got 2 points for the correct conclusion with a proper reason. Part B, find the average velocity of the particle for the time period between 0 and 6. Okay, so this is going to be a simple application of the average value formula. Okay, so the average value across a and b is going to be 1 over b minus a times the definite integral from a to b of f of x dx. Okay, this is the average value of f of x over a and b. Okay, so in this case, all we have to do is plug in our stuff. We're going from 0 to 6, right? And it's going to be 1 over 6 minus 0, so 1 over 6 times integral from 0 to 6 of the velocity. Okay, because we want to find the average velocity, right? So that's going to be 1/6 times the integral from 0 to 6 of 2 sine e t over 4 plus 1 dt. And if you evaluate this in your calculator, you're going to get 1.949. Okay, this was a 2-point question, 1 point for the correct integral and 1 point for the correct answer. Part C, find the total distance traveled by the particle from time t equals 0 to t equals 6. Okay, so for this, since we're looking at distance and not displacement, we're going to be looking at the absolute value of velocity. If this had instead asked us for displacement, we'd just be looking at velocity, but since we want to find the total distance, we're looking at the absolute value of velocity, okay? Or the speed. So what we're going to do is to define the total distance, we have to integrate velocity, or integrate the average value of velocity. Right, this is just something that you should have learned, that to find the distance, you have to integrate the absolute value of velocity. And we're doing this from 0 to 6. Okay, so just fill that in. This is the absolute value of 2. I keep saying e. All of that dt, and then again, this goes in your calculator, right? And you'll get 12.573. Okay. This was a 2-point question. Again, 1 point for the integral, 1 point for the answer. And finally, part D, for t between 0 and 6, the particle changes direction exactly once. What's the position at that time? Okay, so when we want to look at where the particle changes direction, we're looking at where the velocity is equal to 0, because to change the direction, it has to stop and turn around, right? So we're looking at where the velocity is equal to 0. So what I'll do is I'll just take this velocity function and set it equal to 0, right? So 2 sine e t over 4 plus 1 equals to 0. You plug this in your calculator, and you get out that t is approximately equal to 5.196, okay? And now to get the most exact answer, I'm going to store this as a variable in my calculator. I'm going to store it as a, okay? So whenever I reference a in the future, I'll be referencing this t value. You do the same, you plug this into your calculator, you store it as a variable. That'll make sure your answer is as exact as it can be. Okay, so we have our t value where the velocity is equal to 0. And now to figure out the position of the particle at the time, I'm going to use the fact that the integral from a to b of my velocity is my position at b minus my position at a, okay? So if I want to use this fact and I want to figure out the position of the particle at time a, what I can do is let's replace this b and a with 0 and a. A is this t value. Okay, so the integral from 0 to a of the velocity is x of a minus x of 0. This is an application of the fundamental theorem of calculus. Okay, so I can rearrange this to solve for the position at a, and I get that the position of a is equal to the position of 0 plus the integral from 0 to a of the velocity. Right, if you've done physics, you've seen the kinematic equation, that's where it comes from. Okay, so we know that the initial position is 2, because we're given that in the problem. X of 0 equals 2. And then we know the velocity function, so we can figure out that x of a is 2 plus the integral from 0 to a of the velocity function. I'm not going to write it out again, you know what it is by now. Then if I evaluate this in the calculator, I get 14.135, and that is the answer. Okay, this was a 3-point question, 1 point for setting the velocity equal to 0, 1 point for the integral, and 1 point for the answer. That concludes question 1. Question 2. As the pot of tea cools, the temperature of the tea is measured, modeled by a differentiable function h, where t is in minutes and h is in degrees Celsius. You have values of h, and then you need to use the data in the table to approximate the rate at which the temperature of the tea is changing at time t equals 3.5, right? So h of t tells us the actual temperature. So if we want to find the change of the temperature, we're looking at h prime of t, right? More specifically, we're looking at the change of the temperature of the tea at time t equals 3.5. So we're finding an approximation for h prime of 3.5. Okay, so we don't actually know a function that we can differentiate to find h prime of 3.5. But what we can do is we can say, okay, so I'm looking at this table and I see that there's 2 and 5, and those are relatively close to 3.5, right? So what I'm going to do is I'm going to find the slope between these 2 points. So find the slope between 2 and 5, and I'll use that as the approximation for the derivative of h at 3.5. Okay, so basically I'll say this is approximately equal to h of 5 minus h of 2 over 5 minus 2. And I'll actually just make it clear that it's an approximation only, okay? So this is 52 minus 60 over 3, which is negative 8/3. And the units are, well, the units are the units of h are degrees Celsius, and the units of t are minutes. So the units for h prime of t are degrees Celsius per minute. Okay? That is a 1-point question, 1 point for the correct answer. Part B, using correct units, explain the meaning of 1 over 10 times the integral from 0 to 10 of h of t dt in the context of this problem. Use a trapezoidal sum with the 4 subintervals indicated by the table to estimate that. Okay, so basically whenever you see this kind of this fraction times an integral, especially when like the difference between these two numbers is the number in the denominator, it's pretty much like guaranteed. It's an average value. It's the average value of this function in the integral. So in this case, this is the average value of this h of t function, which is the temperature of the t between 0 and 10. So they ask us to explain the meaning of this integral. Well, that's going to be the average value of the temperature of the t in degrees Celsius over the first 10 minutes. Okay? And then now we need to approximate that using a trapezoidal sum with the 4 subintervals in the table. So by 4 subintervals, they mean the first interval goes from 0 to 2, and from 2 to 5, and from 5 to 9, and from 9 to 10. Okay? And the actual calculation of this trapezoidal sum, so it's 1 over 10 times the integral from 0 to 10 of h of t dt. It's going to be approximately equal to 1 over 10 times, okay, so we'll focus on the first subinterval. It's from 0 to 2. What it's going to be, it's going to be the average of these two h of t values. So 66 plus 60, that's not 60, 60 over 2 times the difference in the two t values times 2. Okay? And then now the second subinterval from 2 to 5, it's going to be the average of these two. So 60 plus 52 over 2 times the difference in the t values, which is 3. And then we'll do the same thing for the third subinterval, the average of these two values, so 52 plus 44, 2 times the difference in these, which is 4, I should put it down here, plus the average of these two, which is 44 plus 43 over 2, times the difference in these, which is 1. So if you put this whole thing in your calculator, you are going to get 52.95, and that is the value of the integral here, and that is the value of the average temperature of the t in degrees Celsius between t equals 0 and t equals 10. So in the first 10 minutes, this is the average value of the temperature of the t. Units. Okay, this is a 3-point question. 1 point for explaining what it means, 1 point for the trapezoidal sum, like this part, and 1 point for the answer. Alright, part C. Evaluate the integral from 0 to 10 of h prime of t dt and explain what it means. Okay, well, this is a pretty simple application of the fundamental theorem of calculus, right? So what we've got to do is we have to know that the integral of the derivative, they kind of cancel out, and you just get the original function left over. So the integral from 0 to 10 of h prime of t dt is equal to h of 10 minus h of 0. Okay, so the derivative and the integral cancel out, and we just got the 10 and the 0 plugged into h, and that's what we get. Okay, again, this is just straightforward from the fundamental theorem of calculus. And we know h of 10 and h of 0 because those are both here. H of 10 is 43, h of 0 is 66, and this is negative 23. Okay? And then, now, we want to know, what does this mean? Well, if we just look at this, h of 10 minus h of 0, that's really what that is. That's just delta h. That's the change in temperature between time t equals 10 and time t equals 0, right? Final temperature minus initial temperature. It's a change in temperature. So basically what this means, what this integral is equal to, is it's the change in temperature of 23 degrees Celsius. So it drops 23 degrees Celsius from t equals 0 to t equals 10. That's what it means. This is a 2-point question, 1 point for the answer, 1 point for the explanation. Part D, time t equals 0, biscuits with temperature 100 Celsius are removed from the oven, and the temperature at time t is modeled by differential equation b, for which it's known that b prime of t is equal to blah 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 blah. Using the given models at time t equals 10, how much cooler are the biscuits than the tea? Okay, so this is going to be another pretty simple question. So we just figured out that part C, that's telling us the change of temperature of the t. So then if we did the integral from 0 to 10 of b prime of t, that would tell us the change in temperature of the biscuits, right? So it would be b of 10 minus of b of 0, and guess what? We know that b of 0 is 100, right? So I can rearrange this to solve for b of 10, and I get b of 10 equals 100, which is b of 0, plus that integral from 0 to 10 of b prime of t dt. Guess what? It just happens that we have the equation for b prime of t right there. So all we got to do is plug that in. So we get 100 plus the integral from 0 to 10 of negative 13.84 e negative 0.173t dt. So you put this in your calculator, you will get the answer of 34.183. And that is not our final answer. I just tricked some of you, I'm sure. So what we're going to do now is we have to find how much cooler the biscuits are than the tea, right? We're not done here, so we have to figure out the difference in the temperature between the biscuits and the tea. And how do we do that? Well, we look here. We know that at time t equals 10, the tea is 43 degrees, and the biscuits are 34 degrees. So the difference between these two is h of 10, which is the temperature of the tea, minus b of 10, which is the temperature of the biscuits, which is 43 minus 34.183, which is 8.817 degrees Celsius. And we were done with question 2. Points. This was a 3-point question again. 1 point for the integrand here, 1 point for correctly using the fact that b of 0 equals 100, and 1 point for the final answer. That concludes question number 2. Alright, question 3. Let R be the region in the first quadrant enclosed by the graphs of 8x cubed and sine of pi x, as shown in the figure above. Part A asks us to write an equation for the line tangent to the graph of f at x equals 1/2. Alright, so, like all the other tangent line equation questions, we need two things to make this work. First, we need the point, and second, we need the slope. Okay, so we're at x equals 1/2, so the point is going to be 1/2, comma f of 1/2. Okay, and then the slope, that's going to be f prime of 1/2. Okay, so how do we figure out f of 1/2 and f prime of 1/2? Well, we'll start with f of 1/2. We can see here that this is the graph of 8x cubed, and this is the graph of sine of pi x, right? This is the exponential one, and this is the kind of trig one, right? So we've identified the graphs and figured that didn't matter actually in this situation because they both intersect at this point, and it's labeled as 1/2 comma 1, right? So we know that when x is 1/2, y is 1 for 8x cubed, and coincidentally for sine of pi x as well, but that doesn't really matter. Either way, we know that the point is 1/2 comma 1, right? Because that's the point, really. Okay, and then for the slope, f prime of 1/2, we'll just have to take the derivative of f of x, which is going to be 24x squared, right? You take the 3 and you bring it down, so you multiply 3 times 8, which is 24, and then you subtract 1 from the 3 to get 2, so it's 24x squared. Okay, and then we're evaluating this at x equals 1/2, so 24 times 1/2 squared, which is 24 times 1/4, which is 24 divided by 4, which is 6. Okay, so we have the slope, and we have the point, so all we got to do is put them together, so we get y minus 1, right, that's the y, equals m, which is the slope, times x minus x1, which is the point. Okay, so there you go, that's that. This was a 2-point question, 1 point for figuring out the derivative, and 1 point for putting it in the equation. Okay, alright, part B is to find the area of R. Okay, so to figure this out, we need to figure out this distance, right? Like the distance between the two bounds of R. Okay, and the way we do that is we say, okay, this graph is on top, right? Sine of pi x is on top, and 8x cubed is on the bottom, right? So what we can say is that since the graph on the top is sine of pi x, and the graph on the bottom is 8x cubed, we can plug this into the formula for finding the area, which is the integral from a to b of top minus bottom. Okay, and where a and b are the starting and ending points of R. As you can see here, R starts at x equals 0, and it ends at x equals 1/2. So these are a and b respectively. Okay, so this is the integral from 0 to 1/2 of sine of pi x minus 8x cubed dx. And then, since this is in the no calculator section, we're going to have to do this by hand. So to integrate sine of pi x, we're going to do a u substitution to get just one variable inside this sign. So it's like u equals pi x, and then when you evaluate that, you'll get negative 1 over pi cosine of pi x. U substitutions are a really good skill to have memorized, or like you should be able to do them in your head. Okay, so in this one you simply add 1 and divide. So you add 1, 4 divided by 4, 8 divided by 4 is 2, so it's minus 2x to the 4th. Okay, and then this is being evaluated from 0 to 1/2, right? 0 1/2, and then so if we do that out, we'll get, plug in 1/2, we'll get negative 1 over pi times the cosine of pi over 2 minus 2 times 1/2 to the 4th minus negative 1 over pi cosine of 0 minus 0. Okay, so cosine of pi over 2, that's 0, so I can just kind of ignore this part, and then this is 0, so I can ignore this part. So when I simplify this completely, I'll get negative 2 times 1/2 to the 4th plus 1 over pi, and then cosine of 0 is 1, so it's just that. Okay, you can simplify this if you want, it's not really needed. And in terms of points, this was a 4-point question. 1 point for setting up the integral, 1 point for evaluating the integral, 2 points for evaluating the integral, 1 point for setting it up, 2 points for evaluating it, finding the antiderivatives, and then 1 point for actually getting the answer. Okay? Part C. Write but not evaluate an integral expression for the volume of the solid generated when R is rotated about the horizontal line y equals 1. Okay, so let me draw that horizontal line y equals 1. That is, this color, that is right here. Okay, that's y equals 1. Squeeze it in there, y equals 1. Okay, so how do we find the volume when the region R is rotated about this horizontal line? And the way we're going to do that is we're going to identify little r and big R. Okay, so little r is the distance from the horizontal line to the first of the two graphs, and then the big R is the line from the horizontal line to the second of the big graphs. Okay, this is little r and this is big R. So we need to find equations for each of these two. Okay, so little r is, well, this entire distance here is 1, right? From 0 to 1, that's 1. But we need to subtract this other part, right? We're subtracting the distance from 0 to sine of pi x, right? So we take the 1 and we subtract sine of pi x, and then little r is what's left over. So little r is 1 minus sine of pi x. Okay? And then using that same logic, what do you think big R is going to be? Well, big R is going to be 1 minus 8x cubed, right? Because the entire distance is 1, but we're subtracting this little bit. We're subtracting that 8x cubed, so R is what's left over. R is 1 minus that little 8x cubed bit. Okay? So we found out these, and all we got to do is plug these into our equation. And that's going to be the integral from a to b times big R squared minus little r squared dx times pi. Okay? Now all we have to do is plug in all our numbers. So we have pi times the integral, and now again we're going from 0 to 1/2. So 0 to 1/2. Big R is going to be 1 minus 8x cubed squared, and then we're subtracting 1 minus sine of pi x squared dx. And so that's actually it, because they're asking us not to evaluate it, but just to write the equation. So we don't actually figure out what the answer is. Okay, that concludes that. This was another 3-point question. Well, the other one was 4 points, so not another, but whatever. 1 point for the limit and the constant, and 2 points for the integrand. Okay, that's the third question done with. Question 4. The continuous function f is defined on the interval from -4 to 3. F consists of 2 quarter circles and a line segment shown in this figure, and g of x is 2x plus the integral from 0 to x of f of t dt. Part A asks us to find g of -3, g prime of x, and g prime of -3. 3 and 1. We'd love to see it. So let's start with g of -3, the easiest. Well, I don't know. They're all the same, I think, but whatever. G of -3 is, so what we're going to do for g of -3 is whenever we see the x, we'll replace it with the -3. So if 2 times -3 plus the integral from 0 to -3 of f of t dt. And now this is weird because we're going from a bigger number to a smaller number. My mind does not work that way. So what we're going to do is we're going to switch this to go from a smaller number to a bigger number like we're used to with integrals. Okay? And the way we do that, we can switch the bounds of the integral, but then we have to switch the sign in front. So currently it's a plus, that's going to become a minus, and the new bounds will be -3 to 0, f of t dt. Like that, okay? And all we have to do now is figure out what are the bounds from, what is the integral of f of t dt from -3 to 0, okay? So -3 to 0, that's going to be from here to here, right? This is the graph of f. So from here to here, we have to find the area under the curve. Because remember, the integral is nothing but the area under the curve. So we need to find this area of this quarter circle here. Okay, so remember the area for a whole circle is pi r squared. So the area of a quarter circle is going to be, drum roll please, 1/4 of pi r squared. Okay, and in this case, since r is 1, 2, 3, it's going to be 9 pi over 4, right? 3 squared is 9, 9 times pi is 9 pi, and then 9 pi over 4. Okay, so what this is this is -6, that's -6, minus 9 pi over 4, okay? And that is part A. That was, oh no, that's not the entire part A, my bad. I was getting ahead of myself. G prime of x, right? That's next, g prime of x. Okay, so we know that g of x, see if I can get both of these in frame. So g of x is 2x plus the integral from 0 to x of f of t dt. So to get g prime of x, well, we know that the derivative of 2x is 2, right? And then plus the derivative of the integral from 0 to x of f of t dt, right? And by the fundamental theorem of calculus, the derivative and the integral will kind of just cancel out, and we'll get 2 plus f of x. Okay, that's it. Now all we got to do is we got to figure out what is g prime of -3, right? We did g of -3, and we did g prime of x. Now all we need is g prime of -3, which is the easiest of the 3 parts for sure. 2 plus f of -3. Well, let's go up here. What is f of -3? F of -3 is 0. So this is 2 plus 0, which is 2. Okay. Let's see. This is that was the end of part A. You get 3 points, 1 point for each of the 3 answers. Okay. All right. Part B asks us to determine the x-coordinate of the point at which g has an absolute maximum on the interval from -4 to 3, and to justify our answer. Okay. So let's start with figuring out, how do we know when g has an absolute maximum? Okay. Well, at that point, when there's an absolute maximum, we know that g prime of x is going to equal 0, right? That's the critical point. And we also know that g prime of x is equal to 2 plus f of x, right? That's from part A. So we know that 2 plus f of x has to equal 0, and therefore f of x has to equal -2. Okay? So all we got to do now is figure out where does f of x equal -2. That'll tell us some information about the absolute maximum. Okay, and if we just look at the graph, you see, oh, it goes up, goes up, goes up, and it doesn't seem to reach -2, which is down here. It only seems to reach that at this exact point here. Okay, so that's going to be the point of our absolute maximum. But unfortunately, they don't seem to tell us what that coordinate is, so we're going to have to do a little bit of basic algebra to figure that out. Okay, we're going to start by figuring out the equation of this line. So we're given 2 points. We're given 0, 3, and 3, -3, right? So we need to find the slope of this line, and we need to figure out the equation of this line, right? So the slope, which is m, is going to be y2 minus y1. So if this is y2 and this is y1, it's going to be -3 minus 3 over x2 minus x1 over 3 minus 0, which is -6 over 3, which is -2, right? So now we know the slope. Now we can choose any one of these 2 points to figure out the equation of the line. Okay, I'll choose this one because it has a 0 in it. So we'll have y minus 3 equals -2 times x minus 0. So y equals -2x plus 3. I'm going through this a little bit faster because it's more basic algebra than calculus, right? So we have the equation of the line, and now all that we need to do is set this equal to -2, because we want f of x equal to -2, right? So -2 is -2x plus 3, subtract 3 from both sides, -5 equals 2x, and so x equals, sorry, -2x, and x equals 5/2. Okay, so x equals 5/2. This is the x coordinate of our absolute maximum, but real quick, before we're done, we need to prove it. And that's going to be right here, right? We need to prove that it's an absolute maximum. So if we plug in a number smaller than 5/2 into g of x, so it's going to be, say we plug in like 0, for example, right? We'll get 2 plus 3, because f of 0 is 3. So we'll get 2 plus 3, which is a positive number. And then if we plug in a number greater than 2, so we plug in 3, then it's going to be 2 plus -3, which is a negative number. So we know that at 5/2, g of prime of x, which is from positive to negative, which means g of x, which is from increasing to decreasing, which means that this is an absolute maximum. Okay, so for your explanation, you'd say, okay, so g prime of x is greater than 0 for -4 is less than x is less than 5/2, and then it's less than 0 for 5/2 is less than x is less than 3. Okay, so therefore g must have an absolute maximum at x equals 5/2. This was a 3-point question. 1 point for setting g prime of x equal to 0, 1 point for determining x equals 5/2, and 1 point for a justification. Okay, so part C, find all values of x on the interval from -4 to 3, where the graph of g has a point of inflection, and give a reason for your answer. Okay, so I really like to do a thing where you like show your line of reasoning, how you get from like point A to point B to point C, and that kind of process is going to come really handy with part 4C here. Okay, so we want to figure out where g has a point of inflection, right? So where does g have an inflection point? Okay, and then, okay, so you have to think about, okay, what do I know if g has an inflection point? What does that mean? Well, it means that g double prime of x changes sign. Okay, that's what an inflection point is. It's when the second derivative changes sign. Okay, and then you have to think, okay, so I remember from part A that g prime of x equals 2 plus f of x, right? So I know that g prime of x, or sorry, g double prime of x must equal f prime of x, right? Take the derivative of this side, the 2 is gone, and then the f of x becomes f prime of x. So g double prime of x is equal to f prime of x. So if g double prime of x switches sign, that must mean that f prime of x switches sign. Okay, and then if f prime of x switches sign, well, that must mean that f of x switches direction. Okay, so this kind of step-by-step line of reasoning sort of process, it's really helpful both for you and for your grader to like know what you're thinking. Okay, it'll help you organize your thoughts, and it'll make this process a lot less confusing, a lot more straightforward. Okay, so we figured out now that if g has an inflection point, then f of x switches direction. So all I have to do now is look at this graph and look at where f switches direction. Okay, and we can see that it goes up, 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 and then here it stops and it goes down, right? So the only point where it switches direction is at x equals 0. Okay, so all you have to say is that f of x switches direction only at x equals 0, so there's a point of inflection at g only at x equals 0. And this was a simple 1-point answer. Part D. Find the average rate of change of f on the interval from -4 to 3. There's no point c, where c is between -4 and 3, for which f prime of c is equal to that average rate of change. Explain why this statement does not contradict the mean value theorem. Okay, so it seems like there's some exception to the mean value theorem, but it's not really an exception, and we have to figure out why. Okay, so first we'll start off by finding the average rate of change on the interval from -4 to 3. Okay, so the average rate of change, the formula for that is if we have a and b, it's going to be f of b minus f of a over b minus a, where a and b are the x values. Okay, so we need to find f of -4 minus f of 3 over -4 minus 3. Okay, f of -4 is -1, f of 3 is -3, over -4 minus 3 is -7, right? So -1 minus -3, that's -1 plus 3, which is +2, so we get -2/7. Okay, this is the average rate of change. And now we notice that the next part of the question says there is no point c where c is between -4 and 3, for which f prime of c is equal to that average rate of change. So basically what they're saying is that we know that the slope here, the slope of this line is -2/7, and the mean value theorem says that if the conditions are met, then there's a point somewhere along here where the derivative is equal to this. But we know that in this situation there is no point here where this is the derivative, and we have to figure out why. Okay, and so what we have to do here is think about, okay, this isn't contradicting the mean value theorem because this graph does not meet the conditions. So think, okay, what are the conditions for the mean value theorem? Okay, and then so the mean value theorem conditions are that the function f is differentiable from -4 to 3, right? And then clearly there's this guy and there's this guy, which are not differentiable, right? So f of x is not differentiable, so f prime of x is not defined at x equals -3, in black, x equals -3 and x equals 0, right? So since f prime of x is not defined at those points, the mean value theorem does not apply because the conditions are not met. Okay, so basically all I have to do is say, okay, f prime of x isn't defined at those 2 points, so the mean value theorem doesn't apply. Okay, this was a 2-point question, 1 point for figuring out -2/7, and 1 point for saying why the mean value theorem doesn't apply. Right. Also, you may not have seen this, but this is like a pretty obvious thing. This is a weird function, so this should have caught your attention when you're thinking about why the mean value theorem is not met. All right. Okay, that's it. All right, question 5. At the beginning of 2010, landfill had 1,400 tons of solid waste. We have an increasing function W, that's the total amount of solid waste, and then the amount of solid waste will satisfy this differential equation for the next 20 years. W is in tons, and T is the years from 2010. Part A uses a line tangent to the graph of W at T equals 0 to approximate the amount of solid waste that the landfill contains at the end of the first 3 months of 2010. Okay, so whenever we see the word tangent line, we need to write down two things: point and slope. Okay, so the point, since we're at t equals 0, the point is going to be 0, comma, w of 0, right? And the slope is going to be the slope of that point, which is w prime of 0. Okay, so how do we figure out w of 0 and w prime of 0? Well, let's see here. We know that at the beginning of 2010, a landfill contained 1,400 tons of waste. So that's w of 0, 1,400, right? Because that's how much there was initially. So 0, 1,400, right? And then for the w prime of 0, we know that we have an equation here for w prime, so all we have to do is plug in 0 into here, right? So that's going to be 1 over 25 times, and then for w, we know that at t equals 0, w is 1,400, right? So at t equals 0, I'll plug in 1,400 for w. So that's going to be 1,400 minus 300, which is 1,100 over 25, which is 11 times 4, which is 44. Okay? So now, putting these together, oh, by the way, this is w prime of 0, right? Just to be clear. And so putting these together, we have the point and the slope. So to put those in our form, we'll get y minus y1, so y minus 1,400 equals m, which is 44, times x minus x1, x minus 0. Okay? That is the line, well, I don't need to circle it, but that is the line tangent to the graph of w at t equals 0. Okay? They also want us to use this to approximate the amount of solid waste in the landfill at time t equals 1/4, right? That's simply going to be plugging in 1/4 into here and solving for y. Right? So if we plug in 1/4, we'll get y is, the y of 1/4 is approximately equal to 1,400 plus 44 times 1/4. Right? Actually, I'll make that w of 1/4. Okay, so that's going to be 1,400. Keep in 1,400 plus 44 divided by 4 is 11. So that's 1,411. And then for the units, w is measured in tons, so we'll have 1,411 tons. Okay, this was a 2-point question. 1 point for correctly finding the value of w prime of 0, and 1 point for the right final answer. Part B. Find d squared w over dt squared in terms of w. Use that second derivative to determine whether your answer in part A is an under or over estimate of the amount of landfill at time t equals 1/4. Okay, so this shows that to find out whether your approximation is an under or over estimate, you have to look at the second derivative. Specifically, we're looking at concavity. Okay, so let's find the second derivative. So we'll take this first derivative and take its derivative. Okay, so d squared w dt squared, it's going to be 1 over 25 times the derivative of w, which is dw dt, minus 0, right? So 1 over 25 dw dt, but they said in terms of w, right? We need to write dw dt in terms of w. Well, dw dt is equal to this stuff here, so I can simply replace dw dt with that. It's like dw inception. So we simplify this, we'll get 1 over 25 squared, which is 625, times w minus 300. Okay, that's dw dt. Now we need to, well, here's the, I'll circle that because it's done. And then now we need to say, okay, is this an underestimate over an overestimate? Is our approximation in part A, which remember was 1,411, by the way, is it an overestimate or an underestimate? And then, well, we know that originally there was 1,400 tons of solid waste, right? And then the number just kept increasing because it's an increasing function w. So we know that at least w is 1,400. It could be more, but it's at least 1,400, right? So that means since w is greater than or equal to 1,400, that tells us that the second derivative, since if we plug in 1,400 or greater into here, it's always going to be positive, this is at least greater than or equal to 0. Or I can see greater than 0. Greater than 0. Okay? What does it mean when the second derivative is greater than 0? Well, it means it's concave up. And so let me draw a graph that's concave up, like this. And if I choose a point here, for example, and I draw the tangent line, notice that the tangent line always lies under the graph, right? It's never on top of it. It's always underneath it. So what this means is if this is the actual value, this is the value that the approximation gave. And notice that the value that the approximation gave is always less than the actual value, right? So what does this mean? Well, it means that whatever we did in part A, that's an underestimate. So you can write this out in your actual answer. You'd say part A approximation is an underestimate because the second derivative is greater than 0 for t between 0 and 1/4. Okay? That was part B. So there's 2 points. 1 point for the correct value of the second derivative, and 1 point for the correct explanation that it's an underestimate. Part C. Find the particular solution to the differential equation dw dt is 1 over 25 times w minus 300 with an initial condition w of 0 equals 1400. Whenever you see these solve the differential equation things, you should be silently jumping in your chair. I don't know if you can, you might not want to do that, but you want to be like yes, I got this, because like I always say, these are so full of points, it's insane. Okay, so if there's one thing you want to study before the test, it's these, because this is the best point to effort ratio for sure. So how do we do this? We have a differential equation here, and we need to solve it, right? First step is separate your variables. 1 over w minus 300 dw equals 1 over 25 dt, right? I took the dt to this side, and I took the w over 300 and I brought it down. Okay? Now I have this. I can give it an integrate. Is that it? We should say it. I'm going to give this an integrate. Cool. Okay. Where was I? So yes, we're integrating this, right? So since the coefficient to the w is 1, I can just skip a step and say this is equal to the natural log of w minus 300. If you're not confident with that, you can do use substitution. Just know if the coefficient here is 1, it's just the natural log of that stuff. And then this is obviously 1 over 25 t, right? You can think of like t to the 0, then you add 1 and divide by 1 to get t to the 1. And then plus c, okay? Now we need to solve this for w. So the first thing I'll do to get rid of the natural log is I'll put an e as the base for all of these things. Okay? So the e and the natural log, they will cancel out, and we're just left with w minus 300 equals e to the 1 over 25t plus c, okay? Now we'll add 300. And then one thing I'll do is I'll use the property that, to simplify this, I'll use the property that a to the b plus c equals a to the b times a to the c. So I'll rewrite this as e to the 1 over, I forgot the t there, e to the 1 over 25t times e to the c. Okay, and since e to the c is just a constant, because e is a constant and c is a constant, I can rewrite this as 300 plus ce to the 1 over 25t. This c and this c are different c's, but they're both constants, and that's what's important, okay? Now that we have this, all we have to do now is solve for c. And the way we're going to do that is using the initial condition they gave us. Initial condition is w of 0 equals 1400, okay? So we're going to take 0, 1400 and plug it in. So we'll get 1400 for w equals 300 plus c e to the 0. That's going to go 1. So we have c equals 1400 minus 300, which is 1100, right? So what I'll do is I'll take the c and I'll plug it back in for w. We'll get w equals 300 plus 1100 e to the 1 over 25 t. How cool is that? Maybe not the coolest, but we can pretend. Okay, that's all they wanted, I think, right? They just wanted to find a particular solution. Here it is, particular solution. And this was a 5-point question, right? Like I said, best point to effort ratio. Is it effort to point ratio or point to effort ratio? I don't know, one of those two. We get 1 point for separating the variables, 1 point for performing the integration, 1 point for including a plus c, 1 point for using the initial condition, and 1 point for the final answer. Okay, that concludes question number 5. Question 6, the final question. This one doesn't look too complicated, right? Let f be a function defined by this piecewise thing, and part A asks us to show that f is continuous at x equals 0. Okay, so this goes back to like the very beginning of the year, Unit 1, limits, where we have to show that something is continuous. We have to show that the limit from the left is equal to the limit from the right is equal to the actual value, right? So expressing that in mathematical notation, it's that the limit as x approaches 0 from the left of f of x equals the limit as x equals 0, or x goes to 0 from the right of f of x, which is equal to the actual value of f of 0. If this is true, then f is continuous at x equals 0. Okay? So we need to find out each of these 3 values, alright? So the limit as x approaches 0 from the left, well, if we're going from the left, we're looking at this part of the function, right? That's the part on the left. So as we're approaching 0, sine of x approaches 0, right? Because as x approaches 0, sine of x approaches 0. So then we just get 1 minus 0, which is 1. Okay? And then the limit as x, I can do it in a different color. Blue, red. The limit as x approaches 0 from the right of f of x. Now we're looking at the right part. Plug in 0 into here. We get e to the 0, which is 1. And then finally, f of 0. Well, if we just plug in 0 into here, since we're 0, that's this part of the function. 1 minus 2 times sine of 0, which is 0. So 1 minus 0, which is 1. Okay? So now notice that these are all equal. 1, 1, 1. Now since 1 is always equal to 1, which is always equal to 1, we can say that since the limit, well, you know what? I'm going to be smart and save myself some writing time, and do copy paste. Since blah 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 blah, then f is continuous at x equals 0, right? There's our answer. Okay, this was a 2-point question. 2 point for this answer and explanation. Alright, for x is not equal to 0, express f prime of x as a piecewise defined function. Find the value of x for which f prime of x is equal to negative 3. Okay, again, pretty straightforward, right? We need to find f prime of x as a piecewise defined function, and don't overcomplicate this. Okay, it's not as crazy as you might think it to be, which hopefully you thought it was easy. You literally just have to take the derivatives of both sides and call it a day. Okay, so the derivative of this top side, the derivative of 1 is 0, the derivative of sine is cosine, so it's just negative 2 cosine x. And then this guy, the derivative of e to the negative 4x is negative 4 e to the negative 4x. Okay, and this is for x is less than 0, and this is for x is greater than 0, right? Because they said for x not equal to 0. Okay, so this is that, and then now we need to find the value of x for which f prime of x is equal to negative 3. Let me quickly box this. Box this. Okay, there we go. You've been boxed. Now we define the value of x for which f prime of x equals negative 3. So now there's two options, right? Either this is negative 3 or this is negative 3. So we'll start with the first one. Negative 2 cosine of x equals negative 3. That means that cosine of x is equal to negative 3 over negative 2, which is 3 halves. Now, what value of x is there such that cosine of x is equal to 3 halves? Well, think about cosine, the function of cosine. We know that cosine is defined such that it goes between negative 1 and 1, right? The maximum value of cosine is 1 at like 0 and 2 pi and 4 pi. And it's equal to negative 1, which is its lowest value at like pi and 3 pi and 5 pi, right? So never it's equal to 3 over 2, because 3 over 2 is greater than 1. So this is greater than the maximum value that cosine can be, right? The graph of cosine is like this. and then 3 over 2 is like up here. Okay? So basically, cosine of x can never equal 3/2, long story short. So we'll just put like an x through this part. Okay? Now, -4 e to the -4x equals 3/2. Or sorry, not 3/2, -3. We can solve this pretty easy. E to the -4x equals 3/4. Take the natural log. Then we get -4x equals the natural log of 3/4. Right, remember, natural log and e, they cancel out. And then we simply divide by 4 to get that x is equal to -1/4 natural log of 3/4. Okay? And that's it. That's all they wanted. They wanted f prime of x as a piecewise and find out the value of x, for which f prime of x is -3. The only value that's true is this one here. Okay? This was a 3-point question. 2 points for correctly finding f prime of x, and 1 point for correctly finding the value of x, for which f prime of x is -3. Okay? Part C, find the average value of f on the interval from -1 to 1. Again, a pretty straightforward question, right? You've been asked to find average values of stuff all the time. Okay, so the function for the average value is 1 over b minus a times the integral from a to b of f of x dx, right? F of x is the function that you want to find the average value of, and a and b are the interval, okay? So just plugging in -1 and 1, this gets us 1 over 1 minus -1 times the integral from -1 to 1 of f of x dx, right? All we got to do is evaluate this integral, and we can go home, right? So how do we evaluate this integral? Well, it's a little bit trickier than it originally looks, because what function can we put inside here? Well, there's 2 different ones. Which one do I choose? Well, you can't really choose because it goes from -1 to 1. That covers both of these, right? This is for the part that's less than 1, or less than 0. This is for the part that's greater than 0. So what do I do? Okay, well, what we're going to do is we're going to take this integral from -1 to 1 of f of x dx, and say, okay, I can split this up, right? I can do just this part and just this part. So I can do it from -1 to 0, and from 0 to 1. And if I add these 2 integrals together, then I should get my entire integral, right? And I know exactly what goes in here, and I know exactly what goes in here, right? For this one, it's going to be 1 minus 2 sine x, and for this one, it's e to the -4x, okay? So all we got to do is evaluate these 2 integrals. So the first one, we'll do this. Okay, so this is going to be the integral from -1 to 0 of 1 minus 2 sine of x. The integral of 1 is x, right? And then the integral of sine of x is negative cosine of x. So since there's already a negative there, it's going to become a positive 2 cosine of x, okay? Because remember, the derivative of cosine of x is negative sine of x. So we have x plus 2 cosine of x. This is from -1 to 0, right? So if we plug in -1 and 0, we're going to get, let's see, we're going to get 0 plus 2 cosine 0 minus -1 minus 2 cosine -1. So plus 2 cosine of -1. Okay, so evaluating this, 0 is 0, right? Cosine of 0 is 1. This is 2 plus 1 minus 2 cosine -1, which is 3 minus 2 cosine of -1. Okay, so that is this first integral. Now we're going to do the second one. That's going to be the integral from 0 to 1. And remember, the top part of the function was e to the -4x, right? So that's what we're going to put in here. E to the -4x dx. And now you can do u substitution if you want, but you should be able to calculate in your head that this is equal to -1 over 4 e to the -4x. Okay? You can just think about, okay, what do I have to integrate? What do I have to differentiate to get this? And the answer is this, right? So it's from 0 to 1. You plug in your numbers, you get -1 1/4 e to the negative 4 minus negative 1/4, right, the negative, positive, e to the 0. Okay, so this is just 1. So this is 1/4 minus 1/4 e to the negative 4. Okay, I just rearranged it a bit. So now we know what this integral is equal to, and we know what this integral is equal to. So now we can figure out what this integral is equal to, right? Undo. Okay, maybe. So we know that the integral from -1. Okay, so we know the integral from -1 to 1 of f of x dx is equal to the integral from -1 to 0, which we said was, what was it? We know it is 3 minus 2 cosine of -1 plus, this is the first part, and then the second part, which is the integral from 0 to 1, is 1/4 minus 1/4 e to the negative 4, right? And then now what do we do? Well, okay, so we have this, and now all we need to do is find out the average value, right? And we said the average value was 1 over 1 minus -1, integral from -1 to 1 of f of x dx, right? This is just 1/2. So 1/2 times, what is this? Well, all of this is just equal to this, right? So I'm going to do another copy paste and say, ta-da, that is my answer for the average value of f of x over -1 to 1. Okay? You could simplify this a bit further if you want to, but it's sufficient. It's right? And that's all that matters. So in terms of points, this was a 4-point question. 1 point for deciding to split the integral up into 2 smaller integrals. 2 points for evaluating each of those integrals and getting your 2 correct answers. And then 1 point for putting everything together into your final answer. Okay? That concludes question 6, and that concludes the 2011 AP Calculus exam. Alright, hope you found this helpful, and I'll see you in the next one. Goodbye.